3 number question. 3 number question is, if a equals to x to the power q plus r into y to the power p, b equals to x to the power p plus r into y to the power q, and c equals to x to the power p plus q into y to the power r, then we have to prove that a to the power q minus r into b to the power r minus p into c to the power p minus q equals to 1. If means, my dear student, condition or given. So what is the given here? Given here is a equals to x to the power x to the power q plus r into y to the power p. Similarly, b equals to, we have, how much b equals to we have? X to the power p plus r into y to the power q. Similarly, c equals to, we have x to the power p plus q into y to the power r. These are given. Then left hand side I am taking. What is left hand side? A to the power q minus r into b to the power r minus p into c to the power p minus q. This is left hand side, p minus q. Now put the value. So in the place of a, we can write this. So a means x to the power q plus r into y to the power p, and this q minus r power same. Similarly, put the value of b. B means x to the power p plus r into y to the power q, and this whole to the power r minus p is same. Similarly, c equals to, what can we write? X to the power p plus q into y to the power r, and this whole to the power p minus q same. You know that if there is double power, then power is multiplied. So x to the power q plus r into q minus r. This is in the form of a plus b into a minus b, which equals to a square minus b square. So what shall we write? q square minus r square. And here what shall we write? Double power, then power is multiplied. pq minus pr. Similarly, here also same concept. There is no difference between p plus r. P plus r can be written as r plus p. So r plus p into r minus p becomes r square minus p square. And this becomes y to the power q into r qr and minus p into q pq. Same concept we use here. Then this becomes x to the power p square minus q square, because p plus q into p minus q. And y to the power becomes pr minus qr. Now look here. This, and this. These three have same base, and middle we have multiplication sign, so power will be added. So it becomes x to the power q square minus r square plus r square minus p square plus p square minus q square. Similarly here, the remaining three have same base, y base, and y base. So this becomes y to the power pq minus pr plus qr minus pq plus pr minus qr. Now look here, minus q square plus q square cancel, minus r square plus r square cancel, minus p square plus p square cancel. So in plus minus, if everything is cancelled, then what is left? 0. So this becomes x to the power 0 into here plus PQ minus PQ cancel, minus PR plus PR cancel, plus QR minus QR cancel. This becomes y to the power 0. And we know that anything to the power 0 equals to 1 except 0. So x to the power 0 equals to 1, y to the power 0 equals to 1. 1 into 1 is 1, which is our right hand side. Proved. Now move to 4 number question, which is very, very important for SCU point of view. If means given or condition. So given is P plus Q plus R equals to 0. P plus Q plus R equals to 0. Then we have to prove that, I'm writing the left hand side. What we have to prove? 1 upon 1 plus x to the power P, 1 plus x to the power P plus x to the power minus Q. Similarly, second fraction is 1 upon 1 plus x to the power Q plus x to the power minus R. And third fraction is 1 upon 1 plus x to the power R plus x to the power minus P. And this equals to, we have to prove 1. This equals to, we have to prove 1. Students, this question is very, very important. And in this type of question, we have to make the same denominator. Why? Because if denominators are same, LCM will be same, and then whole simplification will be easier. So to make the denominator same, first fraction I'm writing as it is. Yes, look here. Here we don't have minus q, x to the power minus q. So I'm multiplying numerator and denominator of second fraction by x to the power minus q, so that we can make same denominator. And here we don't have x to the power minus q, so x to the power minus q. Multiplying in numerator and multiplying in denominator. 1 plus x to the power q plus x to the power minus r. Similarly, what is not here? We need x to the power p in first fraction, but we have here x to the power minus p. So multiplying numerator and denominator of third fraction by x to the power p, denominator x to the power p, 1 plus x to the power r plus x to the power minus p. Look here, first fraction is same. 1 plus x to the power p plus x to the power minus q, same. Second fraction in numerator, same, x to the power minus q. In denominator, x to the power minus q, 1 x to the power minus q. And here, these two have same base. And in multiplication, when bases are same, power is added. So this becomes x to the power minus q plus q, which is x to the power 0. Similarly, these two have same base. In middle multiplication sign, so power will be added. So it becomes x to the power minus q plus minus r. So plus minus becomes minus r. So it becomes minus q minus r. And if we take minus common, this becomes q plus r. Q plus r. Similarly here, this x to the power p same. X to the power p, 1 x to the power p. This becomes x to the power p plus r, because in multiplication, when bases are same, power is added, p plus r. And this becomes x to the power p into x to the power minus p, same base. In multiplication, when bases are same, power is added. So this becomes x to the power p minus p, which is x to the power 0. Now look here, first fraction is same. 1 plus x to the power p plus x to the power minus q. If we move to second fraction, numerator will be same. X to the power 0 means 1. And look here, this term I have taken, q plus r. So q plus r equals to, what shall we write from here? Q plus r equals to minus p. So q plus r equals to minus p, and minus we have already here. So minus minus plus, it becomes x to the power p. Similarly, x to the power minus q. This also we have taken. Now what is left? X to the power minus q. Now check. First denominator and second denominator are the same. To make the denominator same, we have multiplied second numerator and denominator of second fraction by x to the power minus q. Similarly, move to third, x to the power p. X to the power 0 means 1. This I have taken. X to the power p same. And p plus r. P plus r equals to what shall we write, student, here? P plus q plus r equals to 0. So p plus r equals to what shall we write? Minus q. Good. X to the power minus q. Now check. All three fractions have same denominator. So when denominators are same, LCM will be same. So what is the LCM? 1 plus x to the power p plus x to the power minus q. And if denominators are same, then LCM is same. Numerator will be also same. 1 plus x to the power minus q plus x to the power p. Arrange this. If you arrange this, then this becomes 1 plus x to the power p plus x to the power minus q. Denominator as it is, that is 1 plus x to the power p plus x to the power minus q. Same, so cancel. What is left? 1, which is proved. We have to prove 1. This is right hand side proved. You can write proved. Yes, dear students, we have discussed lot of question of indices. Hope you people have understood it properly. And on the basis of today's discussions, now I'm going to left some of the questions for practice. You can see these are the questions for practices. You can practice these all questions by using the method that we have discussed today. Now, similarly, you can practice these questions also as a long questions of simplification of indices. Simplification of indices.